Yeah. So we are back. Somehow we are back. Right from back from the grave, huh? Right, okay. So what we were discussing back then was the vacuous truth. Okay. So we were discussing about the vacuous truth, and somehow okay, so what did our board tell us? So vacuous truth. This was something R and W. So I think we were discussing about I think we were studying about the examples in this one, yes. We were studying about examples on this one. So let's see what we have in here. Examples, right. Let's go back to the desktop in here. So it's like this was a statement, right? So this is the mathematics statement, like all integers greater than 5 and less than 3 are prime. It's actually true. There are no such integers, so the hypothesis is also always false, making the implication trivially true, right? So, okay, that kind of makes sense. So, because if we cannot, because we cannot actually, whatever the premise is given. So, in this case, whatever the antecedent is given, since we cannot prove this, obviously we cannot prove the consequent as well, right? So we cannot prove the consequent as well. So now the thing happens in here is that um, so because we cannot prove the antecedent, we cannot prove the antecedent. So the consequent is trivially true. So the implication is that the consequent is trivially true. Okay, so now we have understood this one. Now the converse. Now in converse, we were discussing regarding converse, right? So we were discussing regarding converse. So in here, so one of the converse is like if P implies Q, then Q implies P, but that doesn't mean that they are logically like So in here we have to understand this one, right? So this we were discussing in here. So this we were discussing in here. Okay, let me just clear this one. So suppose if we have one statement, or let's say a more precise word will be, what will be the precise word? The precise word will be proposition. Okay, so suppose we have a proposition. Okay, so suppose we have a proposition. Suppose we have a proposition. So proposition is that uh, P implies Q. So this is the first proposition, right? My hands are still not properly working, but anyways, we can continue with this. Okay, so yeah, hopefully my hand will fix itself and heal itself. Right. So now next, now this is the straightaway implication in this one. So this one is your straightaway implication. Okay. Now when we go back to, let's say, a converse. So converse is like this. It is Q implies P, right? This is the converse. This one is the converse. Okay, this one is the converse. So this is your this one is your converse. Okay, this one is your converse. Now, of course, because P implies Q doesn't actually, reason out that Q also implies P. So suppose, so the example which was given, which I've written in there, was that if the rain falls, so if the rain falls, okay, if the rain falls, right, so if the rain falls, so the rain falls, then the ground is wet, right? So the ground is wet. So in here, having ground as wet will be Q. Having ground as wet will be Q, right? So ground as wet will be Q. And rain, falling of rain will be here, right? The falling of rain will be here, and um, falling of rain will be here, which implies the ground is wet. However, if let's say that ground is wet, then the question remains is the question remains is that whether it is raining, right? So when you take out this scenario, right? When we take out this scenario, this converse scenario. So converse is basically the converse. When you talk about converse, so when you talk about converse, converse is yours. So this is the basic implication. Okay, this is the basic. Okay, okay, this is the basic implication in this one. Okay, so this one is here implied. Right. So this is the basic implication in this one. So this is an implication. Now, when you talk about this portion in here, when you talk about this portion in here, this is basically converse. Okay, I've already written this one. Okay, so this is converse, right? So this is converse, right? So I'm missing an I in here, right? So again, this is P and this is Q, right? I know this looks like some toddler doing some scribbles in here, but like this is the best I can do with my hands right now, uh, because my fingers are like messed up. Anyways, so in any case, so this is implied, right? This is implied that if it is raining, then the ground will be wet. Okay, so this scenario, right? But if the ground is wet, does it imply that it is raining? No, actually not. We are not sure about this. So the converse may or may not be dependent on you know uh, the proposition which was first stated, right? But we understand that this is converse of whatever the proposition was stated. So not a proposition, the proposition which was stated. Okay, so the proposition which was stated was this. So this is the proposition. So this is the proposition. Okay, this is the proposition. So we know that this is the converse of this proposition, but it doesn't mean that if this is the converse, then that this proposition is true, right? So if this is the converse, if you observe this converse, so if you are observing this one, right? if we are observing this one, let's say if we are observing this one, then that doesn't mean that this proposition is true, right? Because the ground could be wet because of a pipe, a hose of gardening as well, a water hose of gardening as well, right? It could happen, right? So water hose of gardening. So ground could be wet because of water hose of gardening, right? So when we observe the converse, that doesn't mean that the proposition which was stated earlier, that is true, right? So that is what we have to understand in this one. Okay, so that is what we have to understand in this one. Okay, uh, converse. Okay, so in here the converse is not logically equivalent to the original. The ground could be wet because of the pipe burst, so Q can be true while P is false. The converse and the original only happen to be equivalent in biconditional relationship. So in biconditional relationship, we only have the converse and the original to happen to be equivalent, right? So when we talk about equivalent is like they both are like dependent on each other. It's most more like they're both dependent on each other. When we talk about converse is more like uh, the consequent is dependent on the proposition, like the antecedent. Uh, the consequent is dependent on antecedent, but when antecedent is there, that uh, antecedent is there, then we are definitely sure that the consequent will happen. But if, let's say, uh, consequent is there, so if the consequent is there, then we are not sure that the antecedent did actually happen, right? So in here, the antecedent is your P and the consequent is your Q. So that is what it is trying to imply. Okay, that is a good amount of calibration in here going on in here. Okay, now, of course, right. This is the so this is quite understandable because um, this book is for like above master, so I think this amount of explanation is enough. I think for this book, do I have to explain it more? Where are the truth tables in this one? Okay. Now the next is the inverse. Okay, so the next is the inverse. So what is an inverse? Both hypothesis and conclusion are negated. So again, there are some synonyms and we have to understand in here. The hypothesis and the conclusion, or the proposition, or and okay, let me see. Right, I'm using a lot of synonyms in here. I'm using. Should I stick with one synonym? Hmm. Then that is what I'm thinking. Like, right. So okay. Um, Let me recalibrate myself. The proposition. mm, semantics. Okay, so proposition is an assertion. Okay, right. Okay. Proposition is an assertion or a statement. Yes. Yeah. So I was using all these words, right? Only assertion I was not using. So I was missing this one. I was only missing the assertion word. So assertion is there. So assertion is more easier to understand because we assert something. So that means um, we are taking this more like a we are just believing this statement to be true, and then we are working towards there, right? So it's more like it's more like axioms as well. Right? So when you talk about axioms, when you talk about axioms, so axiom is a foundation statement principle that accepted as true without needing proof. So assertion and axiom. So let's see, axioms versus assertion. So the only way the difference is like axiom is your foundational self-evident truth accepted without proof, which serves as a starting point of the logical system. So when we talk about axioms, it is something which is like a self-evident truth. So when we talk about self-evident truth is like which you cannot deny with your perception and your senses. Axioms are something which you cannot deny with your perception and senses. That is an axiom. Now, when we talk about assertion is what? Assertion is your statement or a claim. So it is a claim. So technically, assertion is a claim or a statement. That is that is something is true, but it still requires some logical reasoning, evidence, or formal proof to be validated. So we know that some assertion is true. We claim that it is true, but we need some valid reasoning proofs or evidence or some kind of formal proof to be validated that assertion uh, yeah, so it's more like assertion. When you talk about assertion, it is not we are not sure whether it is validated or not. So it is something which is true, but we are not sure that it is validated, right? An axiom is something like from our senses and perception, we cannot deny that it is false. So it is a self-evident uh, truth or something. Yeah. So yeah, it is a self-evident truth. So it is something which we cannot. It is something which we cannot prove as false, no matter what we do. So that is a self-evident truth. So that is an axiom. Okay. Right. Mm. Okay, so I'm remembering things. Of course, I'm remembering things. Now let's go back to it. Okay. Right. So maybe I should add in these things as well. Yeah, maybe I should. So so we have to understand what is axiom, what is assertion, what is statement, and what is axiom, what is assertion, and what is statement and proposition, right? So these things I have to include in this one, right? So these things I have to include in this one. The point is, where should I include this? Is it mathematical logic? Mathematical logic. Hmm. Mathematical logic. Okay. Okay, so we have this like statement, any declarative sentence that can be true or false. Okay. Has a truth value? Yes. Assumed or proved? Neither. It is just a sentence. Okay. Yeah, statements. Proposition. A block of a statement used as a building block in logical reasoning. Neither. It is evaluated. This is declarative, right? This is declarative. This is a declarative phase. Now, when this statement goes into some logical reasoning, then it is a building block of a logical reasoning, then it is evaluated. Okay. And then assertion that a speaker claims to be true. Okay. Claimed, not yet proved. Axiom, foundational statements accepted as true without proof, assumed always as true. Okay. So rather than this one, right, rather than having key rule, which is like just like this one is like just stating that you have to follow this one, right? It's more better to like explain why this is there, right? So why this is there, we have to explain this one, right? A proposition must be a closed sentence. Its truth value must be determined without additional information. Okay. Open sentences like x plus 1 is equal to 2 is called predicates, not propositions until the variable is bound. Example by a quantifier. Quantifier. There exists an x such as x plus 1 is equal to 2. Okay, quantifier. So until unless there is a quantifier, this is a predicate. All right. This is a predicate. So proposition and okay, maybe I could just add some more things in here. So yeah, it's better to like write this not as a rule but rather as a difference in this table as uh, in this table itself, right? So foundational terminology. Yeah, yeah. It's better to write it in this one itself, right? It's better to write in this one itself. So okay, so we are getting somewhere at least. Mm, not able to think right now. Like I'm getting a brain fog or something. Uh, okay. Recalibration, recalibration, recalibration. Okay, so now we have all of these things now. Okay, coding also. Yeah. So in here, statement any declarative sentence that can be true has a truth value. Yes, neither. Okay, assumed or proved. Neither is just a sentence. And then example 7 is odd. Okay. Next is proposition. A statement is used as an atomic unit in formal reasoning. So when a statement is used for a formal reasoning as an atomic value, then it is a proposition. And then has assumed or proved, neither it is evaluated. So this is used for evaluation. We don't know whether it is assumed or whether it is proved. It is just evaluated for the sake of evaluation. Like this, yeah. So let P, it is a reigning. This is another thing. Assertion. Okay. Now, when we talk about assertion, assertion is like a proposition a speaker claims to be true, not yet verified. Okay. So if a speaker claims a proposition to be true and it is not yet verified, that is assertion. Has a truth value? Yes. And claimed, not yet proved. So it is assumed or proved, not either assumed, not either proved, but it is claimed in this one. Okay. So I assert root 2 is irrational. This is one thing in here. Axiom. When you talk about axiom, axiom is a foundational statement accepted as true without proof. Now, this usually happens is because our senses and um, our senses as well as our perception cannot deny that it is false. So that is why it is a foundational statement accepted as true without proof. Has a truth value? Yes. Assumed? Yes. Number two. So it it usually happens in this one is like you cannot disprove it. So you have to assume it is true. So the point of axiom is that you cannot disprove it. Zero is a natural number, Pn. So given by this one. Okay. Now next is theorem. Okay, when you talk about theorems, uh, a significant statement derived from axioms via proof. Okay, so theorem is something derived from axioms. So we have some axioms, and through that we derive a proof. It has a truth value, yes, proved rigorously. So it is proved. So axiom is something which is assumed, and we cannot disprove that it is not true. And from there we derive the theorems. Pythagorean theorems, Fermat's last theorem, these are some of the examples. Then we have lemma. Okay. The Helpel theorem proved specifically to support larger theorems. So that is a lemma. It has a truth value. Yes, it has a truth value and proved subordinate result. So from the theorem, we have something called lemma. So Euclid's lemma is like if P A B, then P A or P B. Okay, so this is like Euclid's lemma, as in like if P is parallel to A B, then P parallel to A and P parallel to P. I have to like look into this one, right? Euclid's lemma. Now, Euclid's lemma is regarding, the prime numbers, or it is the foundational properties of prime numbers. Okay, Euclid's elements. Now, I may have to like take out some pen and paper regarding this one. The old school way you have to go. So let me understand this one again. So when I'm using pen and paper, so so you have like so Euclid's lemma is A and B. We have some A and B in here, right? Two integers. These are integers. A and B are integers. A and B are integers. Suppose D, and then AB is there. D is relatively prime to A and D divides B. The result appear in Euclid's Elements book 7, proposition 30. I think I could get this book. Let me see. Euclid's Elements. Right, so this is so this is proposition 3, proposition 30. Okay, so let's see. Proposition. Mhm. Hmm. Book 7, right? Let's see. That's okay. Proposition 7. This is two triangles ACB on the same base. This is not what it's talking about. It's proposition 30 they're talking about. Okay, I will just look into this later on. For now, like, okay, let me just keep this copy just in case. Um, Okay, let's keep this copy in here. Just keep this copy in here and like I'll look into this later on. Right. And then the next is like the corollary. A theorem that follows immediately and easily from another theorem. Corollary. Corollary. Okay, yes, that is corollary. Of course, it has a truth value. Proof directly flows from a theorem. There are infinitely many primes from Euclid's theorem. Okay, so this is one thing. Right. Okay, so again, one thing I'm missing is like predicates. One thing I'm missing is the predicates in this one, right? And maybe I should just remove these Euclid's examples, right? So predicates is one thing I'm missing. That is true. Predicates is one thing I'm missing in here. Predicates is one thing I'm missing. Maybe I should just add this at that as well. Like the predicates for all these things, I could just like add the predicates as well. Okay, so predicates. Uh, again. So Predicate. An open sentence containing variables becomes a proposition when variables are bound. Sentence. Sentence. It's a declaration? No. It's an open sentence. Okay. Not on its own, neither depends on variables or values. And P of x is equal to x is even. True for x is equal to true, false for x is equal to 3. It depends on the variables. Okay, so there is then one more thing, and it is in there, which is like sentence. I'm missing a sentence in this one. So let me add that as well. It's been 1 hour, so I think I should just, take some break. Um, yeah, I should just, should I take a break? That's working on it like for 1 hour or so. I'm not thirsty. Okay, so now you have the change. Any grammatical unit expressing a complete thought includes all types. Has a truth value, not always. Assumed or proved, not available. Example, close the door, is it raining? Okay. Now we have something called a sentence. A sentence is the most general linguistic unit, any grammatical group of words that expresses a complete thought. It's natural language. In natural language, there are four types of sentences, but only one of them interest in mathematical logic. The declarative states the fact or opinion. Yes, has a truth value and can be true and false. The sky is blue. Interrogative, ask a question. No, not is this. And is it raining? No. Imperative, issues a command or request. No. Okay. Exclamatory, expresses a strong emotion. Beautiful. Only declarative sentences can be statements. Okay, so that is true. Declarative sentences can be is a fact or an opinion. Right? It's a fact or an opinion. Right. The other three types of questions, commands, and exclamations have no truth value and play no direct role in propositional or predicate logic. All right, is okay. Then we have to like split out a fact and opinion as well. Yeah, we have to then split out fact and opinion as well. So the other three types are questions, commands, and explanations have no truth value, play no direct role in proposition or predicate logic. Examples of the sentences are not statements. What is 2 plus 2? Interrogative, no truth value. Solve for X, imperative, no truth value. How elegant that proof is! Exclamatory, no truth value. Examples of sentences examples of sentences are statements. Examples of sentences that are statements. Okay. Are as to like to be, to exist. Right. So are is to like to be, and to be is to exist. Okay, so 2 plus 2 is 4 is declarative and true. All prime numbers are odd. Declarative and false. 2 is prime and even. Okay, right. So next is include fact and opinion. So differences between fact and opinion is also like that should also be included in this one because they're declarative and we have to understand what is a fact and opinion. Fact and opinion, maybe this will fall in somewhere within this bounds as well. So let me just figure this out one. Okay, so Okay, so okay, the fact and statement that is objectively true and can be independently verified. Yes, it has a truth value, verified and not assumed. Water boils at 100 degrees Celsius at sea level. Okay, so that is fact in here. Opinion. A statement expressing subjective belief or judgment cannot be objectively verified. Technically, true or false. It could be true or false. Neither depends on the subject. Proved? Neither. Yeah, so when you talk about opinion, it depends on the subject itself, right? So, mathematics is the most beautiful science. So this is one of the opinions in this one. And tricky case. If a statement looks like opinions but are facts, killing is wrong. Seems like an opinion, but formal ethical logic systems, it may be treated as an axiom. Context determines whether a declarative sentence is treated as a fact, an opinion, or an axiom. So context actually determines it, right? Okay. Mathematical logic. Only facts, objectively true and false statements are admissible as propositions. Opinions are not used because their truth value is not fixed, and logic requires a different truth value for every proposition. Yeah. But then, so the tricky case is like, so the tricky case is like if a statement looks like an opinion but are actually facts, killing is wrong. Context matters, right? Context actually defines whether it is a fact, an opinion, or an axiom, or even other things, right? So context matters. In what context we are talking about. So 7 is a prime number and 7 is an interesting number. Hmm. So why 7 is an interesting number is because we have this opinion that 7 is an interesting number, and then we identified it as a prime number. So we have defined the prime number and identified the prime number. So that is why it becomes now a fact. This kind of like yeah. So any opinion, when we categorize and define it, then it becomes a fact. Oh, that's an interesting observation. I will have to look into this afterwards, right? I have to look into how an opinion becomes a fact. It's mostly because when we have some kind of an opinion and when we categorize it properly by defining it properly, then it becomes a fact. So after definition, we categorize it, and once we categorize it, it becomes a fact. So opinion, once we define the opinion properly, so that we can categorize it, and once it is categorized, it becomes a fact. So it could be so in the language context, it could be um, this actually happens very naturally well while speaking, if I understand correctly. So there are words like clock it. There are words like busing. There are words like ye, fam, other things. So this, the opinion, like aura farming is also there. So aura farming or uh, there are other terminologies in the modern languages itself. So, yeah, so when you define an opinion properly, and then you give that definition, that definition, you categorize that definition with a name, then that becomes a fact, right? Hmm. Mm, no, 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 still not getting it there. But from one thing I understand in this one is like once you have an opinion, you define it, you categorize it, you define that opinion. So from that definition, you can now identify that. So once you can identify it, it belongs to a certain category, and then you name that category, and then it becomes a fact. So that is in here. But then in the linguistic context, so the linguistic context like goes a little bit too in the air, right? It goes too in the air. So I'll go into the linguistic context later on, but right now let's stick with the mathematics and the logic part right now. Okay. Okay. So next is so this shouldn't be in here, right? This should be particular. First order logic is a powerful extension of propositional logic that adds predicates and quantifier allowing. So this would be below, right? This would be below. Shouldn't be in here. Right. So let me just readjust this one. Live streaming, writing a book is rather better than writing it without live streaming. Sometimes it kind of helps in some weird way. Let's let me take a break, something. Yeah, so uh, back to where we were. I think I took a little bit more break than usual, but yes, yeah, hopefully not that much. So where we were, or where were we? Where were we, or where we were? Okay, so convolutions, convoluted stuff. I have to deal with convoluted things. So sometimes I get when I take a break, I have to deal with convoluted things. In any case, in any case. So the tricky case is some statements look like opinions, but are actually facts. Some statements look like opinions, but are actually facts, right? Such as killing is wrong seems an opinion, but in formal ethical logic systems, okay, in formal ethical logic systems, it may be treated as an axiom. Uh, Context determines whether the declarative sentence is treated as a fact, or opinion, or an axiom. Okay, so the context determines, right? Context determines, right? So again, like ethical logic systems. Okay, ethical logic systems. Ethical logic systems. Not getting ethical logical systems. Ethical systems. Okay, ethical systems. University of Minnesota. Ethical systems. All right. There are 8 major ethical systems described in the text of one or more. Let me see. There are 8 major ethical systems described in the text. One more worthy of some attention. They are briefly described here. Neither. Hold on. Let me just. No. Let's go to desktop again, and you'll move this one. If you can move this one, you cannot move this one. I made a duplicate. Again, not required. Right. Right. So there are 8 major ethical systems described in the text. One more worthy of some attention. They are very briefly described here. Neither this presentation nor Quinn's treatment does justice to these ideas. Okay. So ethical systems. Name ideas and other materials that are not mentioned in Quinn text is shown in gray in this presentation. Okay. Name ideas and other materials that is not mentioned. I think Quinn text is right. Subjective relativism, cultural relativism, divine command, ethical egoism, Kantianism, act or utilitarianism. Okay, act utilitarianism, rule utilitarianism, and social contract and situation ethics. It's so they don't provide a proper way to go through this one. They don't provide a proper way to go through this one, like a full print on. They don't provide that. It uses XHTML as well. So um, yeah. Anyway, let's print it out. Is one of one. Let's uh, let's just print. Um, if I open with Chrome browser, yeah. So it only shows like one part of the text. It only shows only one part of the text. So it's not like helping anything. Right. So let me just trash this one and just let's make a multiple PDF copies of this one. Okay. So uh, printing. Let's say this. Let's say this as one. Okay. Then as this one as okay, print. So the ethical logic systems, more like from what I get, like the presentation was very, uh, not dense presentation. So from what I get from the presentation itself is that it's mostly related with philosophical and as well as like yeah, it's mostly related to philosophical logical systems. So when you apply logic to philosophical systems, that is like it comes out as like the ethical logic system. So the killing is wrong seems to be an opinion, but in formal ethical logic systems, it may be treated as an axiom. The axiom, when we talk about axiom, again, the context matters, right? Context matters. Like euthanasia is one thing when uh, a person cannot be, careful and they are suffering a lot. Like euthanasia is also like an option to like consider, right? So yeah, this is a very tricky case. Really a tricky case. Like context matters. What context we are talking about? What context we are talking about? That is we have to consider. Okay. Now next is in mathematical logic, only facts objectively true and false statements are admissible as propositions. Opinions are not used because their truth value is not fixed. Yeah, so again, like in this one, truth value is not fixed. Like, okay, so whether something is a statement or whether something is an opinion, like if the statement is a fact or whether it is a statement is an opinion depends on the context itself. So mathematical logic only applies when when it is in certain context, right? So when it is under certain context, then only like the mathematical the usual statements are fact, and then it will have some objectively true or false statements. Okay. So then we come to like statements and sentences. So what are statements and sentences? So sentences, have I like explained sentences in here? Yeah, sentences is the most general. Okay, sentences here, facts versus opinions, key comparison, statements. So a statement, also called a closed sentence, is a declarative sentence that is either true or false, both, but not both, and not neither. It must have an ambiguous, definite truth value. When you look into this aspect, when you look into this aspect, the The Schrodinger's cat is like it is neither alive or dead unless until we open the box and observe the cat, right? So typically, that state of being a superposition in quantum mechanics and quantum physics, that is not a statement, that is a sentence, right? So typically, it is a sentence, right? Or is it a statement? It is a sentence for sure. It is a sentence for sure. But since it is saying that there is a superposition in here, so the cat is dead and as well as cat is alive until unless it is observed. So if you take the first part of the sentence, so it is both, right? It is both. Mm. I have to run through this, like refer to that equation with this. Uh, I suppose some people say that when you study consciousness, when you study consciousness itself, it is that we build reasoning, we build systems such as culture, governance, logic, science, just so that we could limit our consciousness to certain boundaries. And if we go beyond that, there is only suffering in there. Like so, yeah. To reduce that suffering, we built all these things. We create all these things. We create logic. We create language. Um, we create systems. We create culture. We create governance for all these things. So, I mean, I, I would come to that topic later on, but right now I'm not going to go into the depth of that, like, or the study of the consciousness right now. However, like, yeah, from from the perspective of mathematics right now, the quantum mechanics is a little bit out there, and maybe it is like maybe maybe it is going beyond the mathematics at some point of time. Yeah. So, any case, let's see what else, what else, what else, what else, what else. Yeah. So, statement. Again, then we come into in here, right? We come into in here that axiom is also called a postulate. Now, there should be some difference between axiom and postulate as well. Um, the statement that is accepted as true without proof, it is a foundational assumption on which the entire logical mathematical system is built. Axioms are chosen to be self-evident, consistent and as minimal as possible. Okay, so examples from piano arithmetic is what? Zero is a natural number, axiom accepted without proof. For every natural number, S and the set of n is a natural number, where S is a successive function. Okay, so S of n is a natural number. So for every natural number, S of n is a natural number, where S is the successor function. Okay. And example of Euclidean geometry, a straight line can be drawn between any 2 points. Euclid's first postulate and propositional logic, the law of excluded middle, often taken as axiom. Every proposition is true and false. Law of excluded middle. This is union in terms of Boolean logic, and in terms of propositional mathematics, what it is. I forgot. I forgot. Okay, disjunction. Okay, disjunction. So this is disjunction. So disjunction. Right. So disjunction of P and not P is often taken as an axiom. Every proposition is either true or false, not both. So this what disjunction. So this is disjunction is like it is always true, right? This is always true. So this is always true. Okay, maybe I should just write a difference between axiom and postulates as well. Okay, so in here we have sentence, fact, opinion, statements, propositions, predicate, assertion, axiom, postulate. Okay. A foundational assumption accepted without proof, typically within a specific domain, example, symmetry, assumed never proved. Axiom. Foundational statement accepted as true without proof in any formal systems. So postulates are domain specific and axioms are not technically domain specific. In any, it would work in any formal system, right? Hmm. Right. So let me readjust this one. Right, so we have axioms and postulates as well. So we have sentence, we have facts, we have opinions, we have statements, we have propositions, we have predicates, we have assertions, we have axioms, we have postulates, we have theorem, we have lemma, we have corollary. Mhm. Okay. You know, somehow it will backfire at some point of time because again, like because we are building systems, we are building logic, we are building culture just to limit our consciousness. And when we will forget all these things, or when the one who has made it, the architect who has made these things, they will start to forget these things, they will ultimately not be able to survive, right? How much time has spent in this one? Like, suppose I could spend some more time. Hmm. You know, point is now I'm not able to continue. Uh, I know I have to like fix few things in here and there. Just uh, just forgetting a lot right now. Yeah, I have to like fix this summary of relationships and the heading. Let me fix this one. Okay, so let me just fix the heading of um, foundational terminology. So let me just fix this one. Heading of foundational terminology. This let me just render it and see how it comes in. So, sentence. Right. So these are done, and then I will just go to the depth of propositional logic in depth. Now, in the next stream, probably. In the next stream, probably. Hopefully, I don't have to like scribble these things again.